Welcome to this routing podcast. In this podcast we'll be looking at what is routing and what are they used for, routing protocols, what is a routing protocol and why do we use them, and once we've got an understanding of what routing is, we'll also go through some different scenarios showing you different ways of programming your routers using the routing protocols such as static routing, RIP version 2, EIGRP and OSPF. So what is routing? Routing, according to Cisco, is the act of moving information across an into-network network from a source to a destination. But what does a router actually do? A router is a hardware device that is designed to take incoming information and then analyze it. Once it has done this, it decides whether to forward the information to another network, to discard the information, or send it onto an end device such as your laptop. And these routers, specifically your home ones, are what allows you to be able to get online, buy a new outfit, do your weekly shop, or Skype your mates while playing Call of Duty. So what are routing protocols and what is the point of them? Routing protocols are the instructions that give the router the ability to do what I've just mentioned, to forward, discard and so on of the information. However, as technology advances, so do the routers and therefore the demands on them. This is why the way we program routers has changed. First we had static routing, which was all manually programmed, and now we have dynamic routing, which is basically where the routers can update the routing details themselves. Static routing is what we'll look at first. Static routing is when routers are manually configured to communicate with each other. The information is not automated, so any changes or additional routes must all be updated by someone, and ideally someone who knows what they're doing. Static routing isn't actually a routing protocol, but it's where we start on this podcast. How it works is that each router is manually programmed so that it knows how to send the information to reach the desired destination. A router has a list of known routers that it communicates with, and so do all the other routers. However, with static routing there is an issue that can arise. With each router on the network being manually configured, if one of the connections or even the router goes down, there's no way for the other routers to know that this has happened. As a result, the information will just keep on being sent in the direction of the broken part of the network, and the information will be lost forever. Let me give you an example of static routing. Imagine that it is like someone getting a train. Sorry about that. Anyway, the train is restricted to the tracks, and therefore you can only take the route that has already been laid. In the same way, data sent between routers must follow the manually programmed route. If there is a problem on a track, you won't be able to reach your destination, as the route is now no longer complete. Okay, let's set up our network. As the hands are showing you now, first we need to connect a serial cable from one router to the next. Once this is done, you need to connect a console cable from your router somehow to your end device. In this instance, it goes from the router to a patch panel, and that patch panel then onto a laptop where we will configure the routers from. Okay, so the next clip is going to show you how to configure your two routers through static route, and also show you what topology we're using in the various network addresses. Unlike static routing, where all the paths are manually configured, dynamic routing is easier to set up and can be managed by the router itself. The router delivers and receives the routing messages on the router interfaces. The routing messages and information are shared with other routers, which use exactly the same routing protocol. And whenever a router finds a change in the topology, the routing protocol advertises this topology change to the other routers. Dynamic routing is easy to configure on large networks and is more intuitive at selecting the best route, detecting route changes and discovering remote networks. However, because routers share updates, they consume more bandwidth than in static routing. The router's CPU and RAM may also face additional loads as a result of routing protocols. Finally, dynamic routing is less secure than static routing. Okay, let's move on to RIP. RIP comes in two flavors, version 1 and version 2, and they have a number of limits. For example, RIP has a limit of 15 hops, which means that basically if a network that spans more than 50 hops or routers, they can't go any further than that. RIP 1 also can't handle variable length subnet masks, which is VLSN. This is considered a major flaw in RIP version 1 and makes it class full. Periodic broadcasts of full routing table consume large amounts of bandwidth. This is a major problem also with large networks. RIP version 1 also uses broadcasts to send its information, which means that hosts can't ignore RIP advertisements. Remember that each time a broadcast is sent, every host in the broadcast domain will receive and get interrupted, and it must process the packet to determine if it's something it cares about. RIP version 2 does support VLSN, meaning that it has the ability to have a more efficient addressing, and this makes it a classless protocol. RIP version 2 uses multicast, which means that the host can ignore multicast without having to process the packet. Both RIP flavors send their information around about every 30 seconds. The next clip will show you how to configure your routers using RIP version 2 and also the topology that we'll be using for the example. Now on to EIGRP. EIGRP, or Enhanced Interior Gateway Protocol, is a successor to the Interior Gateway Routing Protocol, IGRP. EIGRP is now open, free, and able to be used by anyone but it was created by Cisco and operated only on their devices. Cisco introduced EIGRP because it needed a protocol with faster conversion abilities, route selection and calculation, and the ability to record information from neighbouring devices. To put it simply, Cisco wanted a specific protocol that was better than anything that was available at the time, and this was the result. But why did they believe it to be better than anything else around? Well, here are some of the examples that might answer that question. Neighbour discovery and recovery. This is how routers learn of the other routers their directly attached networks, and also must be able to know when neighbours become unreachable. This is achieved by periodically sending hello packets out. Depending on whether the packets are received, the router can tell if its neighbour is functioning and therefore exchange routing information. Reliable transport protocol. The reliable transport is responsible for ordered deliveries of packets to all neighbours. As some packets must be transmitted reliably, this aspect of EIGRP can transmit multicast or unicast packets and can choose whichever is more efficient. Dual finite state machine. The dual finite state machine embodies the decision process for all route computations. It tracks all routes advertised by all neighbours. This information is then used to find the most efficient loop-free paths. Dual also checks the topology, if a new route is needed to be established, by looking for other neighbour routers that advertise the destination rather than computing an entire new routing table. The next clip will show you how to configure your routers using EIGRP and also the topology that this scenario is using. Finally, we have OSPF. OSPF, or Open Shortest Path First, was created as a replacement for RIP due to RIP's limitations. For example, OSPF has no hop count limit, whereas RIP did. It supports VLSM, RIP version 1 didn't, but version 2 did. OSPF uses IP multicast to send link state updates. It has a fast conversion and allows networks to be divided into areas, which is very useful with large networks because you can divide it all up into smaller groups, easier to keep track of. Right, the next clip will show you how to configure your routers using OSPF and the topology that will be used for it.